Hello, I'm Jeff Hannon, Eastern District Manager for Engineered Systems. Today we're at Gorman-Rupp's Engineered Systems facility in Mansfield, Ohio, and we're in one of the demonstration areas for Gorman-Rupp where we have our priming tower set up today, and we're going to run through a couple of different scenarios and look at some applications and do a little troubleshooting that may help some operators out in the field. And at this portion of the demonstration, we want to talk about the priming capability of the pump. And right now we've got the pump is on a 15-foot suction lift, and we do not have any check valves in the system. No check valves on the suction side and no check valves on the discharge side. So every time the pump shuts off, we are going to drop the suction leg because we are vented to atmosphere, and we will not only drop the suction leg, but we'll also pull and siphon water out of the pump casing down to what we call a reprime level, where there will only be water in the bottom half of the pump. Most pumps, self-priming pumps that are out there, will talk about a dry prime scenario, which a dry prime situation is talking about a full pump casing and a dry suction leg, and most people will most manufacturers will publish how long it takes that pump to prime at a given speed with a full pump casing and a dry suction leg. The only problem with that scenario, when you're talking about a sewage pump station that's in an unattended application, is that the pumps typically don't fail like that in the field. A pump in the field is going to fail or have to reprime when the suction flat valve or discharge check valve gets held open by sticks or rags or strings, or any kind of debris would hold those check valves open and vent the system to atmosphere. When that occurs, we lose a half a pump casing of liquid and drop the suction leg, and now if that pump cannot get itself primed, it's a service call. Somebody has to go out there and fill the pump up with water. All of our T-Series and V-Series pumps are designed so that they can reprime, or that they only need a minimum of a half a pump casing of liquid to get themselves primed. So there's no reason for someone to have to be out there filling these up with water when they lose prime in the field. So to demonstrate that, I'm going to start the pump up here, and we'll just see how quickly this pump can prime itself on a 15-foot lift at 1750 RPM pump speed and a 3-inch suction line. So we'll go ahead and start that up, and then when I stop the pump from running, you'll see also the water falling down the suction leg, but also water siphoning out of the pump casing. So let's run through that demonstration here real quick. Now the pump has gone dynamic, but since there's no check valves in the system, when I shut this pump off, not only will we drop the suction leg, as you see the water coming back down the suction leg, you'll also notice that we're siphoning water out of the pump casing. And we will continue to do that until we get to about the eye of the impeller where the suction and discharge meet. You can hear it kind of settling out, where the pump has now broken siphon, and we're in a situation where now we have a dry suction leg, a 15-foot suction lift, but now we only have a half a casing of liquid in the pump. And if the pump, like I said, now can't get itself primed, it's a service call. Somebody has to go out in the field, fill the pump up with water to get it primed. But again, all of these pumps are designed with the worst case scenario in mind. The only thing we publish is our reprime data, which again is that worst case scenario, which is a half a pump casing of liquid and a dry suction leg. Just to show you that we've got as much water out of the casing as would naturally happen in the field, I'm going to start the pump up, and then when just before the suction line goes into the pump casing, I'm going to stop it again and drop the suction leg, and we'll pull just a little bit more water out of that pump casing. If you watch at the top of the suction pipe, when that drops, you'll notice we'll pull just a little bit more water out of that pump casing. Now again, you can never do this with regular piping, but with glass pipe I can kind of watch And again, just by doing this abnormal action, I can continue to pull a little bit more water out of that pump casing. What I'm trying to demonstrate here is that to let people know that that pump maintains enough excess liquid in that pump casing to get itself primed. So even going through a couple of cycles of pulling additional water out of that casing, I still maintain enough liquid in there to do a 15-foot lift in about 30 seconds. So if I go ahead and let this thing go through a full cycle to prime, we'll go ahead and let it start, and we'll actually deliver flow this time. Now we're up at full flow. So if we go ahead and stop that, again with no check valves in the system, we're going to set up that scenario again. But again, the pumps are designed so that they can reprime themselves in an unattended application out in the field. When the check valves get held open by sticks or rags or any other kind of debris and the system gets vented to atmosphere, and the scenario that you're seeing here happens, and you're left with just a half a pump casing of liquid and a dry suction leg, this pump can reprime and get itself to a full pumping state in a matter of seconds. And that concludes this portion of our demonstration.
बंद कर होंगे फिर टाइम है इसमें गैस नहीं देगा आप लोग गैस नहीं है फोन के ना फिर टाइप